So far we've been testing hypothesis for means or averages. Now we're going to go ahead and look at proportions. So we will have our null hypothesis and our alternate hypothesis, which brings up one of my favorite cartoons. I can't believe schools are still teaching kids about the null hypothesis. I remember reading a big study that conclusively disproved it years ago. So anyways, we reject the null. You get that? Anyway, so sometimes instead of means, we are comparing a sample proportion, p hat, to a hypothesized proportion, which we'll call p naught. All right. We call this a one proportion z-test or a one prop z-test if you're using the TI-84. Now, as before, we start the null hypothesis, which is in the written form that p naught is going to be some value k, which is the hypothesized null value. It is not the statistic from your sample. So, for example, if we were looking at what percentage of babies born are male, you would assume that it's 50%. All right, so K would be 0.5. So we can calculate from the sample the p hat, or the statistic, by dividing the number of successes, x, by the sample size, n. All right, so n is the total number of attempts or the sample size. By the way, sometimes on WebAssign, you might see an R instead of an X. We then test the hypothesis using one of the three forms below in your note. Now recall that P naught is always the null in our model, okay? So we could do a left tail test where we're saying P naught is that's actually less than our hypothesized value K. So K is to the left of P naught, and we then shade to the left. All right, so that's where would it be? And you would basically do your normal CDF, where your left boundary is negative infinity and your right boundary is p hat. All right. Actually, it should be, whatever you got on your sample. All right. Then we can do a right tail test where p naught is greater than k. So k is to the right, and we shade to the right. And we say, okay, the probability that p naught is greater than p hat, and your left boundary is p hat, and then infinity. Okay. Or we can do a two-tailed test where we're saying, oh, p naught is not k. We have both a left and a right, so we have to shade outside of both. So we're basically going to find the probability of either this one, and I'm using this one here, and doubling it. All right. So your left boundary is going to be, your right boundary is infinity, your left boundary is p hat, and then you would basically just double that. This is again assuming that p hat is higher. If p hat is lower than p naught, then you actually want to use that one. Okay. But there are easier ways to do this, so don't worry too much. All right. So for proportions, we're going to use the normal distribution, which is z-test, because if we know the hypothesized value p naught, which we might have, might think of k as well, if we know that, then we can actually calculate the standard deviation. And we're not going to use p hat, which is the statistic. So we have sigma is p times q over n. Remember, use the hypothesized value. So we'll have our left boundary, our right boundary, whatever that is, depending on the situation, and p naught, and then sigma for p naught. All right, so you'll use a normal CDF like we did before. The p-value represents the probability of getting the data you obtained, or more extreme, given that the null hypothesis is true. Now we can also calculate the test statistic by hand. It's going to be p hat minus p naught all over the standard deviation for the hypothesized proportion. The good news is most calculators and software will do this just given your x and your n and your p naught. So you don't typically have to calculate the test statistic, and they'll also tell you what z is. So conclusions are pretty much the same. If the probability is low, then we're very surprised, and we reject the null and change our minds and say, hey, we have evidence to change our mind to the alternate. Our level of alpha is usually 0.05, but it can be lower, like 0.01, but those are typically reasonable levels of alpha. So if you get a p-value lower than 0.05 or 0.01, you can say because our p-value is, whatever it is less than 0.05, we reject h naught. There's convincing evidence that the true proportion is and then whatever your alternate hypothesis is. The only difference when we get a high probability value is that we're not surprised. So we fail to reject. We're like, oh, that's not that unusual. You're not going to change my mind. And we say, there's not enough evidence to change my mind. All right. So we fail to reject and we say there's insufficient evidence. So it's very similar to the other, except we're going the other way. All right. So let's go ahead and look at this example for smoke detectors. A 1996 report from the U.S. Consumer Product Safety Commission claimed that at least 90% of all American homes have at least one smoke detector. A city's fire department runs a public safety campaign about smoke detectors. They want to determine if the campaign has raised the local level above the 90% national rate. Building inspectors visit 400 randomly selected homes and find that 376 have smoke detectors. Is this strong evidence that the local rate is higher than the national rate? So we're going to go ahead and create a null and alternate hypothesis and determine the p-value and make a conclusion. So what are we assuming? We're going to assume this 90% that's up here. So p naught is 0.90. What are they trying to do? They're trying to raise the proportion above that 0.90. So that's our alternate. We're hoping that the data is going to change our mind that it from 90% of people have smoke detectors to more than 90% have smoke detectors. Now, they went ahead and gathered a sample, so that's going to be our p-hat, 376 over 400, which is 0.94. Now, we can go ahead and find sigma, and that's, remember, use your hypothesized value, 0.9 and 0.1 over 400, which is 0.015. All right. So if I was going to do the probability, I'm saying, okay, I want the probability of getting this extreme or higher, given that the mean is actually 0.90 and the standard deviation is 0.015. So the most common mistake that will occur on a problem here is miscalculating sigma because you accidentally use your sample instead of your hypothesized value. So that is the most common thing, that if you have the wrong sigma here. And but the rest is pretty much what we've been dealing with. And so the probability we get that p is actually greater, that the true proportion is greater than 0.94 is 0.0038. So is that a high or low probability? That's actually a very low probability. So because our p-value of 0.0038 is less than 0.05, we reject H naught. There's convincing evidence that the true proportion of homes that have fire alarms is greater than 0.90.
Now, the good news is we can use stapplet to do all the math and not have to do it by hand like we just did. So first of all, go to one categorical variable single group. Make sure you put in your variable name. It's sort of optional, but it's good practice. And we need to, in the first row, we need to enter the number of successes. In this case, that's the number of smoke detectors, and we put in the frequency 376. Then we have to calculate the number of failures. So that's your sample size minus the number of successes. In this case, it's 400 minus 376, which is 24. And we go ahead and enter that in the next row. Then we click on Begin Analysis and scroll to Perform Inference, where we'll see something that looks like this. Select your one sample z-test, and let me go ahead and make sure I've got my laser pointer so you see it right there. Make sure the category is the one that marks success, in this case, smoke detector. Make sure the alternative hypothesis matches the direction. So in this case, we wanted greater than the hypothesized proportion of 0.9. Click on Perform Inference to get the report for the test statistic, t, and the p-value. And here's your walkthrough, how to do the stapplet. So we have homes with smoke detectors. Success is if they have a smoke detector. And the frequency, we had 376 out of 400 homes. So that means no smoke detector would be 400 minus 376. Don't type it in that way. Put in 24 and hit your Begin Analysis. Scroll down until you see Perform Inference, and you want to make sure that you're doing a z-test. And so you have, make sure the success matches, which was the smoke detector. You can see your data there. And we want P, we're hoping that our campaign worked, and then we actually have it greater than 0.90. And we perform it, and our z-score is 2.667, and our p-value is 0.00383. Again, make sure you have one sample z-test. Smoke detector is your category. Our alternate hypothesis was greater than 0.90, and then there you go.